Hello. Welcome to our first workshop. This is the complete guide to InfluxDB 2. Today's workshop, we're going to be exploring one of the more challenging parts of InfluxDB 2 for people that are just not familiar with querying with Flux. There are a few challenges and quirks to this brand new query language that you only learn through guided tuition or plenty of headbanging against the wall. So I'm glad you've chosen this approach. Now, this is a workshop. This is the first time that we've done that in this course. And the format will be, there is a README file on GitHub where you can read through all the materials and do the exercises. What I'm going to do today is read through all the materials and do the exercises. Now, I'll give you plenty of warning before I move on to the exercises, so I would encourage you to follow along with me as we go through the materials, and then don't watch the exercises. If you're watching live, well, yes, please watch the exercises. But if you're not watching live, pause it. Use that as an opportunity to go and test your own logic. Anyone who joins me live today, we will try and make this a little bit more interactive than previous sessions via the tutorials and the lectures. But we want this to be fun. So we have our screen shared here. You can find the resources for this course at github.com/rawcode-academy. I have started adding the materials to the courses repository. There is a InfluxDB complete guide, and we are starting on part 5 today, an introduction to Flux, the workshop. Excuse me. Now, this course is a living course. This course will be continuing to update week after week, and possibly in the future as new features and things come and change with InfluxDB 2. So I can't exactly go back and modify a live stream. So you may see a little bit of variation and change from what is in the README during today's session, but I will do my best to follow up with more workshops as required and as the material evolves over time. Okay, let's see. So in order to dive into Flux today, we do need to start collecting some... Oh, that's annoying. Well, let's get rid of that. Phew, glad I noticed that early. It's just a watermark. That's what it is. Okay, so in order to explore Flux today, we need some data. So we're going to get InfluxDB 2 running on my machine. We're going to run with this configuration from Telegraph. So I'll copy that. We will jump over here and we'll paste it in. As the instructions note, you will need InfluxDB to be running an organization called Rawcode Academy with a bucket called Workshop. So I will do that now also, and I'll just make sure that I don't have any pre-existing data. So we'll run InfluxD, and I'll get another terminal here, and we'll just give that a few seconds to run. I haven't worked out why it takes so long on my Mac, but it just seems to be my Mac, and I'm assuming it's because I'm on the latest beta of macOS Monterey. So maybe something weird going on here. Perfect. And nice coffee. Okay, so let's get our InfluxDB cooking. Oh, localhost 8. Close but no cigar. Localhost, oh, not HTTPS. There we go. So we're going to click get started. My username, I'll pick a password. We want our organization to be Rawcode Academy and our bucket to be Workshop. Now, zooming in on Influx UI is really difficult. So we'll maybe just have to try and make do with this. I'm going to click configure later. We'll go to data and tokens, and we get an admin token created for us, which I will copy. and we will export this as influx token. We can then run telegraph like so. All right, let's close that. And that's all these instructions here are also saying. So we created our organization, we named our bucket workshop, and we exported our influx token environment variable, and this config will just work for you. Now, the configuration of Telegraph that we're using here is just configured with a high resolution or short 2-second interval so that we are collecting metrics every 2 seconds. We want to see data quite fast here today. And we've got a flush interval of 6 seconds. That just means that Telegraph will collect metrics every 2 seconds. It will hold them in memory, and every 6 seconds, it will write them to the database. Really, our flush interval would be higher in normal circumstances, and we leverage batching and buffering much more. However, we do want a pretty quick feedback cycle as we query and work with Flux today. Now, we are configuring Telegraph with the CPU plugin, although I have disabled the total CPU metric, just to force us to do that through aggregation functions within Flux. And we'll talk about that as we move through today's workshop. I've then got it configured with all the other system metrics. So we'll be looking at disk I/O, memory, net, processing swap, and system. These are pretty much all the plugins that work across all operating systems, don't really require any configuration, and get you data pretty fast that is variable and changes. Again, important for what we're working on today with this workshop. Okay, so now we are going to write our first Flux query. And the markdown here will be great, and it is public. Anyone can look at it, but only Raw Code Academy members will get to see this course and my wonderful added commentary and flavor. So while there are things on, while there's little snippets of information in this markdown file, I'm going to be adding on a little bit more and showing you some tips and tricks from my usage of InfluxDB over the years. Okay. So there are 2 functions that are always required before the Flux engine will execute any query against InfluxDB. Excuse me. Excuse me. Now, you need a data source. You have to tell it where to read the data from. And secondly, you need a time window. We'll see this as from and range statements. And there are multiple ways to actually execute a query against InfluxDB. So the first one is we can come here to the Explorer view, where we get this nice user interface where we select the bucket, we can select the metric that we want, we can select the fields that we care about, and we click submit. And you'll see in the last 5 minutes, we've got some data coming through. This UI is great for exploring when you're not really sure what you want to be querying quite yet. But it is quite restrictive if you want to do anything a bit more advanced or complicated. Now you can switch from filters to groups and begin to group by, the values that are available. But really, what we want to do for the majority of the time is to use the query builder. So we click on query builder and we can actually see the Flux code itself. So the first tip here then would be use the query builder whenever possible to at least bootstrap and start your query. It's a really great way to get that from range and any filters through a very visual means. And then from here, you can start to change all of the query yourself. We're not going to use this because we're going to stick to what is available in the workshop. And I'll also show you one more thing in just a moment. So let's copy our from statement. In fact, we'll just copy both of these and then I'll read over the text. But there we go. So what I've done here, and you'll see that it took a little bit longer, is that we have a from and a range with no predicates, no filters, no nothing. And it does return quite a lot of data. And it's hard to tell, but there is probably a fair bit. If we click on this view raw data tab here, which is one of the most important tabs as you start to explore your data, you'll see we've got a fair bit of information here. Okay, so with this data source, the from function is how we select where to load the data from. when you're querying against InfluxDB2, you can use from with a bucket name, and this will fetch data from that bucket. Buckets have retention policies. They're a very good way to determine how long your data should live and use them as a cascading strategy for your data. We're going to be talking about downsampling on Thursday, where we will look at buckets and retention periods in more detail, but not today. The other thing that's worth noting here is that Flux, while is embedded in InfluxDB2, has always been built with the intention of querying multiple data sources. So there are other functions besides from to read from SQL compatible stores, CSV, HTTP endpoints, and others. But we'll only be working on InfluxDB2 for this workshop. Next, we have to use a range statement. And a range statement has accompanied with this little pipe forward operator, and I've kind of done my best to explain this here as well. So if you've written any Elixir or F#, the pipe forward operator should be something you're familiar with. All it means is that we take the output from the first function and we pass it as an input to the second function. So this from selects all data from that bucket. We then pass it into this, and this is a range which will actually filter the data to just the bits that we need, which is the last 15 minutes. Okay, so you always need a from and you always need a range. Now, something else that's cool about Flux, and you've already seen that with our first query, is that it has a concept of a duration literal, which just means that durations and times are first-class citizens. You'll see here, we do a dash minus 15m to say find me data from now minus 15 minutes. We have seconds available to us. We have hours. We have days. That's supposed to be weeks. I'll fix that. So that's a W. We have months denoted by MO. And we have access to years. So, you know, pretty flexible. There are sub-seconds, duration literals too. You can do milliseconds and nanoseconds. Time literals work in multiple ways. You can use a now function to get back the current time. You can use just the year, month, and day, or you can use a full ISO 8601 time, like so. Now, something that is implicit in the query that we have used so far is there was no yield here. InfluxDB actually adds this yield to your query automatically for you. So you can always imagine that it's there if you omit it. And when you do more powerful queries across multiple data sets and you're yielding multiple results, the yield will become much more useful. This will be something we look at throughout the course, especially as we move into monitoring real production systems. So yield, you can omit, but you can also name it as we do here. So you'll see that we have a couple of queries here. The first one is a from range of 15 minutes. We have a filter, which we haven't really talked about yet, but will be something that we talk about in due course. And then we yield that as that data set as CPU. And then we do the same here, yielding as memory with a different filter. And we should be able to what did I get wrong with it? Oh, I forgot that. Is it v yield? Oops. Here's another tip. You can, when you're using the UI, you will get this list of functions on the right-hand side. This is invaluable, right? You're never going to remember the syntax for all of them, just as I have forgotten. You can type the name of the function you need and literally just click inject. And you'll see here, I just forgot the name, named parameter. So that's a really good point. All functions in Flux take named parameters. You'll see that with the range has a parameter called start. It also has a parameter called stop. So we could say, give me 10 minutes of data starting 15 minutes ago, like so. The filter function takes a function called fn, the property is called fn, and then it takes an anonymous function inside. The yield takes a parameter called name. So all functions in Flux take named parameters. And let's see, if we maybe just look at this as raw data, we can see this is the CPU results. And if we scroll down, still CPU. There'll be, where's this memory start? Oh, there we go. Available up. Where are you? I'll try and drag back up, but it's a bit finicky. Okay, there's usage system. That's the end of CPU. Too much data. There we go. And there's our memory results set here. So you can see that donated to you. So you can yield multiple things. Really cool if you want to graph things and build correlations and be able to look at how your CPU is affected with your memory. Like, is there a correlation that as memory consumption goes up or CPU usage is going up, etc.? Now, that's a contrived example. Your infrastructure, your applications, you'll know what you're looking for and what you're trying to correlate. Okay, so that is our very first Flux query. We've taken a look at from and range and yield. Those are just the things that are required for everything you do. Filter is equally important, but we're going to talk about that in just a moment. I'm going to run through the exercises now. So if you want to do the exercises on your own time, or you want to do them now, or you want to try them before I run through them, now is the time to pause your video and come back later. I'll count to 10 in my head while staring intensely. I stopped counting, but I don't know when the 10 seconds is. All right, I'll do. Okay, so the exercises are nice and simple. We're going to layer these up week after week and add in more complex examples. But really, we just want to get you familiar with entering the query into the UI. And then we'll take a look at the Flux CLI REPL as well. So we want to fetch all metrics over the last 5 minutes. So we can say from bucket. And the InfluxDB UI does use language server protocol and Monaco, the VS Code editor, so you will get relatively good autocomplete. Workshop, range, start, -5m. That's exercise 1. Really simple. In fact, we already had a variation of this right at the start as we were copying and pasting. So really, you just want to be familiar with the pipe operator. Know that it's 2 characters instead of just 1 that you may be familiar with from shells, with bash scripting. So we do have the greater than sign, and it's important to remember. And hopefully you get comfortable with the named parameters. A lot of people trip up with that. And then the duration literals. And what a lot of people do at the start as they're writing their first Flux queries would be to forget the minus. And just remember that you need to, it's a duration, right? So you have to go back 5 minutes to get the actual time that you want to query. So we'll take a look at one more thing from here. I'll just open a new tab. And if we run influx, we can see there are a bunch of, where is going on with this terminal? I've had problems with iTerm for a while now, to be fair. Okay, so we can execute Flux queries on the command line. I guess all of my influx commands are going to be acting a little bit funny. All right, when in doubt, open a new tab. Let's just take a look at the help on this. So we can pass in a query that we wish to run. So we could say from bucket workshop range start 5M. Oh, and yeah, we will need a few extra parameters as well. So when we do this on the command line, we will need to provide our --org, which is raw code academy. And we need to export our token again. So it should still be in my history. That's a very old token then, apparently. Let's grab it from, yeah, we'll just grab it from here again. Export influx token. Not the same. Oh wait, it's invalid expression. Compilation failed, not authorization. From I can't remember actually if Flux cares about the quotes. Let's do this. From bucket pipe forward range start go. Oh, and fix the end one. There we go. So quite a lot of data there. Yeah, an awful lot of data. And I have to remove the REPL. Oh, that's a shame. Oh well, you could compile Flux from source, and there is a REPL, but I think it's been removed from the Influx CLI. That's unfortunate. We won't be using that today. This one is definitely broken. That one's definitely broken. Those two are happy. All right, perfect. So we've seen the CLI, we've seen the UI. One more, and there is a VS Code extension. So if we jump over here, search for Flux, you'll see that there is this VS Code extension from Influx Data. We can add connections, say local HTTP, local host. So I've got my token and my organization name. And you can see we get a success down here when we test that connection. So let's save this. And that means that you can run Flux scripts. So we can say run query. We need a Flux file. That's right. So query.flux from, and we get awesome autocomplete from the IDE. Again, using the language server, which the team have been working on. Academy. Range start -5M. Yeah, let's just run that. Let's build Raw Code Academy. Oh, yeah. Workshop. Workshop. The organization is the academy. So we can run this query. I think it's just loading all the data. Getting there. Really, I should have narrowed down that query before running it. All right, let's do that. Let's just grab 10 seconds. There we go. And now we can query and look at this data in our VS Code. So it's entirely up to you. It's still quite a lot of data for 10 seconds. Maybe I've got my interval too quick. So it's up to you. I like using this for the autocomplete and function autocomplete and help text and other stuff. But the web UI is also equally as good. And then the CLI is there if you want to be able to automate or build scripts around any of this stuff as well. Okay, so that was exercise 1.1. Now we want to fetch all metrics for the last hour, excluding the last 5 minutes. So really, we're just coming back here saying 1 hour, only we're adding a stop because we don't want the last 5 minutes of data. That's going to be a large query as well, but the UI should be able to handle it, he says, hopefully. And then the last one is we want to fetch all metrics for the last 3 hours returned as multiple data sets hourly. Yeah, there we go, data. And there's just one thing I really want you to take away from this last task, is that we want all metrics for the last 3 hours hourly. So what does that mean? Well, we can do 3 hours dash 2 hours and just copy and paste that, where we move down to 2 hours and 1 hour, and we move down to 1 hour without a stop. And we can yield each of these. Name 1 hour. And we'll call this 2 hour and 3 hour. And that will work fine. Something else you can actually do is assign the output and then reuse it. It's not very useful in this case because it's just a from statement. This then being reused across multiple ranges. But as your queries become more sophisticated and you're doing a lot more, you may have a set of from, range, and filters that you want to be able to reuse across multiple yields within a single Flux script. And that is entirely possible. And we'll take a look at just how that works next, because we're about to take a look at filtering windows and aggregations. Cool. Okay, so hopefully, that first 30 minutes of this workshop just gets you acquainted with writing Flux, the different interfaces that you can use for submitting your queries and working with the data. The UI is a great place to start. Everyone should start there first. And then move in to the CLI, VS Code, whatever, as you need. The VS Code option becomes much more appealing as we start to play with Packager, which is a manifest format for applying InfluxDB configurations to InfluxDB, kind of like kube control, where YAML manifest. We can do all of that with InfluxDB to manage everything from a GitHub pattern. So it's actually quite nice to be able to work with that in VS Code and have all your queries saved in local Flux scripts. So we'll be doing more in there. Okay, so all of our querying has been extremely superficial thus far, and that's because we aren't doing anything useful. We're just pulling out raw data and actually seeing that with the 30 minutes of data that we're already collecting and ranging over even a few minutes of that can be quite intensive. And it's just because we're collecting relatively a lot of metrics for this little MacBook to handle. So we want to be able to make sure that we are using filtering effectively and efficiently when we query InfluxDB. So leveraging things that will allow the actual time series database itself to help us with the filtering, so we don't have to do it all in memory. And we talk about that in this next section. Phew, alrighty. So what's important here would be this, right? So I'll read this verbatim and then talk about it. The filter function can filter data on any field in a dataset. This means that you need to be particularly careful when adding filters and ensure that you understand when filtering on a tag or a field. If you think back to the lecture we had at the start of this course, lecture 1, an introduction to time series, I talked about how tags are indexed within the time series database and fields are not. Now, because fields are not indexed, if we used a filter function to filter on a field, what actually happens is all of that is loaded into memory and essentially looked over and filtered as required. However, if we use filters against the tag values, which are indexed in the time series database, we can actually just push most of that down to the TSDB and say, don't give me this data or only give me this data, which is substantially more efficient on memory and faster on CPU. So make sure that you're constructing your queries appropriately. So the filter function, and we'll do this by here. The filter function takes a parameter called fn. Right? Fn is not a keyword. A lot of people make this mistake when they first start adopting Flux. Fn is just a named parameter. And it takes an anonymous function. And that anonymous function should return a Boolean, or must return a Boolean value of true or false. If it returns true, the data will be kept in the data set. And if it's returned false, the data will be omitted. Now, you've already seen me do this now, but using the show data toggle is the fastest way to really understand your data as you start querying in Flux. So, we don't need that right now. I definitely don't want an hour. Well, there isn't an hour, but let's just get a little bit of data. We can remove the yield and use the implicit. I won't bother changing it to a minute. Right, so you can kind of see this. Well, no, you can't because of my face. There's a little tiny wee bit of data here. And that's just because we're trying to show, we've got this set to 5 minutes, but we're only pulling back 1 minute. There's not a lot of information here, right? Like if I wanted to start filtering on my data that lives in the workshop bucket, I don't really know how to do that without having substantial knowledge into how it works. So you can use the show raw data button, and we'll kind of talk about how to navigate this big blob of text here. I'll bring my face back in, but if it gets in the way, I'll remove it. So this raw data view that we have in the UI is a annotated CSV almost. Now, what we have here is that information on the data types for each of the columns in our CSV. And we have some group key information, which we'll be talking about as we talk about groups moving forward. We have a result, which is our data. We have tables. We have value. We have the start and stop period. So this will tell us about our range within the query. We have the time that this point value was stored. Now, all of this is stored in a columnar fashion in the TSDB, which means all of the fields that we store, we'll need to pivot them to see them as row-based data. Again, stuff we'll cover in subsequent videos. Don't worry about it if you don't understand what I mean by pivot the data. But because this is columnar, we have a field called _field, which has a value, which tells us which field we're querying against. And we'll take a look at that as we start to build up some of these filter queries as well. Fields belong to measurements. So this is our CPU measurement. There will also be a memory one, a system one, a processing one, etc. down here. And then we have some tags. So this is a CPU 0 that tells us, this is a 16 core machines. We're going to have CPU 0 to 15. And then the host that the data was collected. And this is just based on what Telegraph writes to our time series database. But using this show raw data toggle is the best way to understand how to build and construct your query. Unless you want to use the query builder, of course you can do that too. So what I would see here is that I could filter on measurement equals CPU and field equals usage guessed to really quickly break down this data to just 1 or 2 things that I want to see. So let's copy this query here. So this is a from bucket workshop, range of 15 minutes, and we only care about the CPU measurement. That means we're saying goodbye to disk IO, memory, network, processes, system, and swap. There we go. That was a quick tour. We run this. And I know 50 minutes seems like a short window, but with that 2-second resolution, that is actually quite a lot of points. So we're getting 30 points per minute times 15 across 16 cores. Very quickly adds up. And you can see just by scrolling on this, you know, we've got at least a few hundred tables going on there. So yeah, this is filters. Now, you can add as many of these filters as you like. And we don't want to filter our measurement again. Let's say we just want a single field. Then we can do usage guest. That should be a pretty quick query. And now we only get a single field for each CPU. So we're still got the 16 CPUs, but the field for each. I think what is important to take away from filtering is that the database will work out optimization to make that as fast as possible, as long as you keep all of your filters together wherever possible. Of course, you're always going to need filters further down the stack, and that's okay. But anything that you want to reduce as much of your data set as possible right after the range, because that, as long as you're using tags, will push it all down to the time series database. So you don't need to load all of that into memory. And that's is going to increase your performance substantially. If we were to call another function here, and I know you don't know what window is yet, but that's all right. Those filters being broken up can no longer be optimized because we have some logic that has to happen in between, meaning the only filter that will get pushed down to the time series database is a measurement. We load everything into memory to perform the window. And then even if this is a tag, it doesn't matter. We're still filtering it in memory. So really important to understand and try to remember that if you can keep your filters to the start, you're going to have a much better performing database. Okay, now it's really your own personal preference now, whether how you structure your filters. And what a lot of people like to do is use the AND word. And you can say usage guest and do that as a single filter. You can have them all as individual filters. It does not matter. Personal preference, use whatever you like. Me, I kind of prefer separate filter lines as much as possible because I think it's a little bit cleaner. Of course, if we get down to a certain point here where I have others and I have to do a slightly later filter, then in order to avoid looping over the data twice, although there still are performance things that happen with the runtime that will try to avoid that, I will use the AND syntax. So, but essentially, for the first bunch of filters, I do like to do them together. So this is one filter in the runtime, not two. In fact, that's also arbitrary. I could have as many filters like this. These would all be filtered at once and pushed down to the time series database as long as they're tags. And that is always the caveat with querying in InfluxDB2. Stick to tags as much as possible. Push the field filtering as late in the call or the script as possible. Okay, let's talk about these results that we've been getting. And to do that, we have to explain tables and grouping. So Flux returns all data from your queries as a set of tables which are grouped by a group key. This group key by default is each series within your data, where a series is a unique combination of tag and values. Definitely make sure you've checked out the first lecture, Introduction to Time Series. I talk about series, tags, and keys. But let's take a visual representation of this. So I'm going to remove this. we will pull out 6 seconds of CPU. Whoa, what to do? Okay, 30 seconds. Oh wait, I think, did the 6 seconds work? Can I just... Oh no, because my flush interval is 6 seconds. There we go. Yeah, okay, so view raw data. Okay, so we have got a from, a range, and a filter, right? These are the basic constructs of all Flux queries. You'll see we have table 0, we have table 1, we have table 2, we have table 3, and so forth, all the way down the stack. So a table is a series based on the default group key. The group key that's being used here is our field name of usage guessed, the measurement of CPU, the CPU tag, which is, you know, each CPU will become its own series, and the host. So what we have here is a set of tables for every CPU core on this machine and for each field available in the data set, which I think is anywhere from 8 to 9. I'm not entirely sure. But let's try and make this more visual. So if we add in a new filter and we do field equals, and we drop this down to one field, we should see one series for each variation of the series, which now, because we have constrained the field to a single one, will be the CPUs, meaning we should see 16 tables. Okay, table 0, table 15. 0 for 15, 16 tables. Tables are the thing that trip everybody up at the start. Trying to get the data out, because it's columnar, and you know, not a lot of people are familiar with querying against columnar databases. It's really fast on the read path and the write path, but it comes with a little bit of a cognitive overload that people just aren't that familiar with. So I hope you understand tables. If not, leave comments on the video, jump into the Discord. Happy to spend more time on it, and we'll be looking at it in a little bit more detail as we run through this too. But really, hopefully you have a good grasp of it already. Okay, and we'll copy this just so I can make sure the query. Oh, there's a nice little copy button. Never noticed that before. I'm not going to do 5 minutes. Let's just do 30 seconds. There we go. Now, I think I ask a question here. Yeah, I do. So looking at this query, how many tables do you expect this to return? Okay, so from and range, we filter on the measurement, and we are requesting 3 different fields. I'll give you a moment, or you could pause it. And the answer is here. In fact, I won't even read the answer. Feel free to peruse that at your own time. But hopefully you got it right. Okay, so now we can change the group key to get the data in a format that we need. Again, once you have an understanding of what values you want to get from your metric data and your event data, you can start to piece together your queries, and you'll have a better understanding of the group key that you need. So let's assume that we want data above but grouped by metric, ignoring the different CPUs altogether. So I don't want a table for each CPU. What I want to know is, can I have an arbitrary number that tells me of whether my CPU is saturated or not? So we do a from range, we filter on the measurement, and then we filter on the 3 fields that we want: usage system, usage user, and usage guessed. Now we're introducing the group function, where we can provide the number of columns to use, or which columns to use as a group key. Here, the measurement is actually superficial because we're grouping on the field. If we had multiple measurements with a field name that was duplicated across them all, you would want to make sure that you restrict it properly, and you don't have like response time and multiple measurements all get grouped together because it would skew the values. So it's usually best to be as constrained as possible. So measurement, field, and then the mode of bag. And then if we run this, we'll see that we get all of the CPU numbers in the same table. Perfect. And we'll have 3 tables. You can see the 2 on the left here, and that is for each of the fields. So now we have a table for each field that we care about, and we can actually do aggregations across the values, across the CPUs to understand whether the system is under load or not. All right. Oh, how many tables do you think we'll get back now? Oh, I just answered that. Sorry, spoiler. Something else I like to share with people, because again, it's one of those first questions I get all the time about Flux is, but what if I don't want a group? What if I just want a single table? And you can do that through an empty group. I tend to call it a flatten the data single group. I think that's just a term that maybe I use. I haven't heard a lot of other people use it, but it's just basically no group. We want to remove the group key. So if we jump in here, we can call an empty group like so. And now the zeros all the way down. So that just gives us one flat table. And the use case for that is just having a single series for graphing or pulling out explicit values from a bunch of aggregations that you're making across your data. All right, let's try and get through this last bit within the hour. And I'll be back on. The next video will drop in just a couple of days. Okay, so windows and aggregations. There's a little note here I just want people to be wary of, is that MO and Y behave slightly differently when they're used in window operations in regards to the from. So if you use 1 month for 1 year in a from, it will go back 31 days or 365 days. However, in a window operation, they are calendar aligned. So if you say window this data by month, you will get the first of the month to the end of the month. And the same for years, you will get from January 1st to December 31st. So just keep that in mind. I think that's intuitive, like what people would expect. However, it doesn't hurt to reiterate it, of course. So what window functions allow us to do are to divide the data that we're querying into windows that we want to build aggregations for. So let's, as an example, we are collecting our CPU data every 2 seconds. That is quite high resolution for a CPU on a standard Linux machine. As you can see by some of the queries have already tickled the box a little bit. So we probably don't want to understand the load at 2-second intervals because there are going to be bursts in CPUs as applications are spinning up and down that send instructions to the CPU that cause that number to artificially go up, or not artificially, it goes up, but it's just not that important because it drops back down very quickly. So it's very common with time series data to say, okay, I have 2-second resolution, but I actually want to build an aggregation at 1 minute, 5 minute, and 15 minute intervals. Hey, you may be familiar with that already, right? Linux load averages. So here's a pop quiz. I'm about to run this query. How many tables will it return? So this does a filter and a filter. So we've got a single measurement, a single field, and we're windowing. And we know that I have 16 CPUs on my machine. So keep that in mind. Have a guess. Pause it if you want to work it out for a minute. I am going to go run this query. So 15 minutes of CPU data windowed every 1 minute. I'm going to window it. Well, in fact, yeah, I should run it as one because that's what I said, right? 256 tables. Is that what you got? Okay. If you want that explained, the answer is here. So depends on how many CPUs you have on your system. my machine has 16 CPUs, so it returns 256 tables. Why? Well, we have requested a single metric, and we have 16 CPUs, so you may have guessed it, 16 tables would be returned. However, because we're modifying the group key with our new window, and that's important to remember, windowing data does modify the group key. What we're actually saying is that we want 1 minute intervals. And because our range is 15, we are actually multiplying the number of tables by 16. The reason why is that we get our 15 minute 1 minute intervals plus the current interval, depending on how far into that we are. So we can actually just take a look. So let's try and start at the top. And you can see the windows on the start and the stop. So we have 1435 to 1436, and you see that is not a complete minute because we are halfway through this interval approaching this, whereas the other intervals are complete. So 1444 to 1445. So hopefully that makes sense. Windowing changes the group key. We're building artificial series based because we're saying chop this data up, right? So we're getting Unix series because we're bringing time into the dimension of the window. Something that's usually quite cool about doing that though is the colors. So let's take off the window because I want to show you this. This is cool. What we see here is consistent colors for each series within data. So each CPU core here gets its own color, as we can see in the legend. So CPU 0 is a very light blue, CPU 9 is very orange, and then we've got this cascading color change through. And that consistent is the series color is consistent across the x-axis. Now, when we window the data, we are having a unique series for each window within the data. So actually the colors now change along the x-axis. You can actually see that our first series is this time window here. Our second series is this time window here. Our third series is this one here. Our fourth series is here, and so forth, all the way across there. So I always like the colors when you do that. Very cool. Okay, now we have windowed data, which is great. We have colors, but we actually need to do some more. We want to be able to aggregate that, right? We have 16 values across each 1 minute interval, and we want one single value across each of those intervals to understand the CPU total load, not per CPU. So one of the things we could do is use the aggregate functions. The one we're using here is called the mean. So we want to calculate the mean across this window. I'll remove that. So this is the same query as before. CPU filter, usage user filter, window by 1 minute. In fact, if I remove this, I think it's just a range change, but it's still the same data. We can. I should think. Well, yeah, I'll explain something. You're probably wondering why all my data shows on the right here, and it's just because I'm using a fixed range here. If we use the variables, time range start, we'll use the whole thing, and then we control it through this here. I should have explained that earlier. I just tend to use dash minus 5m so that because it's easier in the markdown than saying click on this. So there you go. Now we can bring in the mean. And if we view the raw data, we're going to get a single value for each series, which can't be graphed because a single value for each series is a point. So you'll see the points along the graph. And just to show you how this was working, there was one line that I removed. So let's copy that again. The one line I removed was just drop this down to a single CPU. Run it again, we get a single point. And if we view the raw data, We just have 1 point per window, like so. Okay, so how many tables? Well, you can read the explanation for that there if you wish. What's important here is that this combination, in fact, did I go into the group there? Yeah, I do talk about the group here. So you can read that just in the interest of time. There's only a few minutes left, but this is a very common operation to do a window aggregation and then flatten or regroup, change the group key. Is one of the most common time series queries that you're going to do against your data. So much so that there's a helper called Aggregate Window to do this all for you. So if we come over here, we can just say, I'll just remove this, measurement CPU, field usage user, window 1 minute, calculate the mean, click the go button, and there we go. And we'll use our time range start so we can get the full graph. And now we're starting to get nice graphs that show the CPU load over time on this machine at 1 minute intervals. If we want to flatten this out a bit, we probably do it at 5. Of course, I'm going to need more data points, so let's do this. And now this is what we expect, right? As you work with Grafana and InfluxDB, Prometheus, all of these tools, we just want to be able to understand fluctuations in values over time at windows that we decide that resolution is important to us, so that we can have a graph that represents normal, so that we can alert on not normal. And that is fundamental to what we're doing today. So aggregate windows, you can do it manually with a window, with an aggregate function, with another group, or just use their function. And in fact, if you pull up the InfluxDB docs, the implementation of aggregate window is the window function group, like so. So there are exercises here. I was hoping I would have time to do them today, but I won't. What I will do is I will schedule, or I will record myself doing each of these exercises and get that uploaded as a tutorial session in the course. Please go in and check out exercises 2 in your own time. Use the Discord to ask for help. Use the comments to ask for help. I'm here. I want to be able to help you. So that is workshop 1, an introduction to Flux. I hope you found that useful. Let me know how you got on. I'll speak to you all soon. Have a wonderful day.